Okay, so we are going to start with a new topic, which is about interrupted flow facilities. And this is from chapter 5.4. So it's a part of chapter 5. And as you may know, that the difference between interrupted and uninterrupted facilities is mainly the intersections. So in this chapter, we will be talking about intersections and the devices which are used on the intersection for managing traffic. So interrupted flow happens, as I mentioned, at intersections. We call them add grade intersections as well, because both roads intersect at the same level. It can happen between two roads, or it can be between more than two roads as well. Okay, two roads is more common. What happens when you have intersections and we have conflict points? What are conflict points? The points at which there's a chance that vehicles from different paths can come together. Okay, points which have potential of having two vehicles going in different paths. These are called as conflict points. Okay, so in this figure you can see conflict points and their different types. So there are three types of conflict points: you have crossing, diverging, and merging. So you can see blue ones are crossings. So if you see here, a car is coming from this side, the other one is coming from this side, and then they are crossing each other. Similarly, the crossing can happen at different angle as well. So a car which is going or taking a left turn from here, and another one which is going straight. So the crossing can happen between them as well. So two cars going in different directions, their paths are crossing each other. Then we have diverging. Diverging means that there were two cars which were in the same direction, but now one of them chooses to go to another path. So for example, these two. So you see this one is going to the right hand side, okay, and then there would be another one which will go straight. So that makes it a diverging conflict point. Okay, same thing here. There could be one car which is going straight, another one which is going left. So that becomes a diverging conflict point. And then we have the converging conflict point, which means that two cars from different paths are now merging with each other. So the orange ones, you can have a car which is taking a left turn from here, and then you have another car which is coming straight. So there's a merging between them. Then we have whichever car is coming from here, and then another car which is taking a right turn. So another merging between them. Okay, one thing you have to keep in mind that once the conflict point happens, after the conflict points, we don't consider them as different cars. You consider them as one vehicle, one car. So you see this one, two cars have already merged. Now I will not make two converging points here, because these two are now one. Okay, they already converged. Similarly, this one, so this one after diverging from here, this is one car, this is another car. Okay, until the next converging or crossing or diverging point comes, this is one car. Okay, so after the conflict points, we consider the cars that they whatever has happened has happened. Okay, now from this point onwards, one car will go one by one. Okay, so from this point onwards, each car will go one by one. Okay, and these two pictures also show you the conflict points for an intersection without a roundabout. This one is with a roundabout. So you can see there is no crossing basically. All crossings are done. And even the right turnings, so the only thing remaining with the roundabout is right turning. Okay, so I'm right turning onto the roundabout or off the roundabout. And you can see that this is onto the roundabout, this is off the roundabout. This is the only thing which happens. So it happens on all four sides. You have 8 conflict points, but here you have 16 crossings, then you have 8 diverging and 8 converging. So in total there are 32 conflict points without the roundabout. So this gives you an example why do we need control devices at the intersections. So from 32 to just 8. Okay, the effect of one control device. Okay, so we have control devices to control the interaction of vehicles at the conflict points. These are the critical points. So these control devices will assign right of way to vehicles to pass in different directions at different times, maybe from different places or whatever. It depends upon the type of device you have. It will, like I've shown you in the previous slide, it can reduce the conflict points as well. So conflict points are totally gone. It can happen as well. For example, control device can be a traffic signal, it can be a yield sign, okay, means a give way sign, it can be a stop sign, it can be a flashing beacon as well. So what is a flashing beacon? It's a signal which flashes, so it alerts the driver that you cannot go forward straight away, like you have to go with caution. Okay, so it gives the other driver more time because this driver is taking care and so on and so forth. Okay, we can have unsigned and uncontrolled intersections as well, and this can be allowed on low volume residential areas. Okay, so there's a possibility that intersection may not have any control device. So in those cases, what happens? The drivers go according to their judgment. They follow the local laws like right hand first, and they follow their judgment. Okay, and they may communicate with each other. They may look at each other and see who wants to go first, who is in a hurry. They can use hand signals, flashing lights. We use flashing lights in Bahrain. So uh, now the idea of removing the signal is becoming popular. Okay, and it's not by putting bridges and so on because that's expensive. So what people are saying that okay, let us just reduce the conflict points using some other methods and remove the signals because signals then become red and they can cause a long queue. So there is an example which is given in the book that uh, in a small town they did this and from the whole town they removed the signals completely, okay, and replaced them with roundabouts basically. And according to the book, that the idea worked, but obviously it may not work at all locations at every time. Okay, so what traffic control devices do? They stop one movement, allow the other. So the part of the time when the movement is stopped is not available to them. Okay, obvious example: a signal. Signal becomes red. That part of the time is not available to you. It's available to somebody else, and that somebody else will also have a red at some point of time. Okay, so these traffic control devices, they reduce the amount of time in which a movement can happen from certain directions. Okay, so obviously when you reduce the amount of time available, the capacity will go down. Okay, so for example, if you can handle 2000 vehicles per hour, now I reduce it to like you don't have 1 hour now, you have 40 minutes, so you cannot have 2000 vehicles, you will have less. So in this sort of way, so they have given an example that without signal, a straight road may handle 2000 vehicles per hour per lane. With a signal, less time will be available and it may be only 1800. So the focus of traffic control devices is to see how much time should be assigned for safe and efficient movement of operation of the intersection. So obviously safety is the main concern here. Safety is the main concern, but at the same time we want the time to be proportionally divided. So movement which has more volume, we want it to have more time as well, and vice versa. Okay, some pictures which are showing different types of traffic control devices. You can see stop signs there. Okay, you can see a signal, not very clear, but obviously you know a signal. Okay, you can see a roundabout there. Okay, yeah, roundabout usually have give way signs, like they are by default give way for entry. So if you are entering, somebody is coming from the other side, you give way to that person. Okay, roundabouts are becoming popular mainly because of safety, because for any other intersection, when you are entering the intersection, your angle is straight. Okay, like you are going in right angles or straight. But roundabout, even when you enter, your angle is reduced. Okay, so if there's a conflict, then it will happen. It will not happen at head on or right angle. Okay, so if you look here, this one now, see, yes, so the angle is reduced. Okay, so this guy cannot go this way, and nobody can come from this way, okay, and hit him. So the angle, even if somebody makes a mistake on the roundabout, the angle of collision is less. So safety, uh, there's a higher potential of ensuring safety. And secondly, when you are entering the roundabout, because you're using your judgment and you are entering on a circular path, so your speed is also less. So reduction in speed and angle of collision makes a roundabout safer. Even as I already shown, that the conflict points are also less. And roundabouts can adapt to different changes of traffic volumes. So when you put a stop sign or a signal, so then you have to worry about the signal timings. You have to adjust it yourself. The volume is from one direction higher, you have to adjust the signal timing for that direction. If you put a stop sign, again, that sign is fixed. You cannot take it away. Yeah? Like I will come in the evening and take it away. It cannot happen. So you have to keep in mind that uh, the control device which you are using, that has to work permanently for all traffic situations. In roundabout, this issue takes care of itself. So you are on the roundabout, you will go in the same manner in high traffic condition and low traffic condition. What's the manner is, you have to wait for the other driver. If there is no other driver, you will enter. So for 2 hours, if there is no other driver, you will not stop for anyone unnecessarily, which can happen on a signal or a stop sign. Okay, so roundabout is more efficient in this way. Obviously, roundabouts are they look more aesthetically pleasing to the eyes. You can have greenery over the roundabout. We have some roundabouts in Bahrain where we have the clock tower or some other monuments. Okay, so they can be used for landscaping as well. It is suitable for pedestrians and bicyclists because vehicles are approaching it at a lower speed. Okay, and this is a fact that 48% reduction in crashes, meaning road accidents, was observed in US with the roundabouts. Okay, like they experimented, like let us change the intersections to roundabouts, and they found 48% reduction. Okay, and this is some data from Bahrain. You can see it for 4 years. Okay, and these locations are in these 4 years locations with highest number of accidents. Okay, and you can see all of them are more, like most of them are signals. From 22, only 3 are roundabouts. Okay, only 3 are roundabouts. All others are signals. So signals are can be more problematic as compared to roundabouts. Okay, now the with roundabouts, you can have a 2-lane roundabout or a single lane roundabout. So there's a graph. Obviously, there are other methods as well. You can do detailed calculations. Okay, so there's a whole procedure to calculate the capacity and find out the number of lanes according to that. But this is a shortcut according to average annual daily traffic and left percentage of left turning. So average annual daily traffic, the average traffic of the whole day from all directions. Okay, so you put it on the y-axis. Then on the x-axis, you from AADT, what percentage is left turning. So again, left turning from north side, south side, east side, west side, and you add these percentages together, and then you put it on the x-axis. So let's say your AADT is 25,000. So 25,000 is here, and let's say your percentage left turning is 10%. So 25,000 and 10%. So a single lane roundabout is enough for you. Okay, above this line, double lane roundabout. Okay, on in this side of the arrow, double lane roundabout. Okay, so this whole portion is double lane. Above this curve is double lane, and only this portion is single lane. Okay, so and you can check this, like I told you, this is a shortcut method, but you can look for more detailed methods in the books as well. Okay, so some features of the roundabouts I mentioned here. We put them normally in circular shape, otherwise unless there's a problem with the space available. Okay, it can have more than one lane. Okay, and because of the circular movement, the speed is reduced. As I mentioned, all entries are considered to be yield or give way. Okay, and they may not be any need to change the lanes to exit. Okay, so you can just exit if you are in the right lane. Okay, so these are some of the features of the roundabouts, and then we will start with the calculations, a small example for the roundabout using the same graph tomorrow. But a point here that obviously with more volume I need more lanes. So you can see here more volume, double lane. Okay, but what is happening here? Okay, the volume is less, but I'm still going for double lane because of the left turning. Okay, so more left turning means more people will be going through the roundabout, so they will not take the first or the second exit. Okay, left turning means you will come from here and you will take this exit, right? So most of the people are rotating the 3/4 of the roundabout. Okay, so then we provide more lanes. Okay, so most of the people are just going straight and right. It's not a problem. Okay, but there are many people, not most, many people who will be using the almost the entire roundabout, so it's better to give them more lanes. Okay, so this is it.